hours of lithium-ion cells, and China is about an order of magnitude ahead of us on that. We're also behind in the electrolyte manufacturing by significantly a lot more. Today, the US accounts for about 2% of the cell electrolyte manufacturing in the world, and China closer to 7%. So they are really dominating the market today. So my question to the audience today is, how does the US secure the electrolyte supply and stay in front of the innovation curve? So I hope I can put out a few suggestions there for all of you today. So today we're all using a conventional liquid-based electrolyte in our lithium-ion cells. LiPF6 and a mixture of carbonate-based solvents, basic mixture we all know and love. So we are scaling this electrolyte production up right here in the US today. There's a lot of investment going into it from the Biden infrastructure law and things of that nature. And that's great. That's really going to help out solving the supply chain problem, but not really the innovation problem. How do we stay ahead of the curve? There's a lot of good people in the audience today that are busy working on solid-state electrolytes. Really interesting technology, has the potential to increase energy, improve safety, but it's still several years away, I think a lot of us can agree, and doesn't really solve the supply chain problem. So it's really innovative, but where's the supply going to be? And so I'd like to introduce the liquefied gas electrolyte today. I think a lot of you already know about it. Much like propane for your barbecue grill, propane is a gas at room temperature and room pressure, but can be liquefied under a moderate amount of pressure and stored in a tank underneath your barbecue grill. We're not using propane per se, but other gaseous materials that happen to work very well inside your battery device. And so what I'm suggesting is that we look to leverage the established gas industry to enable rapid innovation and at a large scale using this technology. The lithium-ion battery market today is $50, $60 billion and growing. The electrolyte component of that is only about $2 billion. The gas market, on the other hand, has been established, and it's right here in the US manufacturing a lot of gas today, and it's on the order of about $130 billion. Imagine just tapping into that gas market today, an established supply chain right here in the US, and just mixing those gases together, adding a little salt in there, and creating a really innovative product. It solves both the supply chain and the innovation problem to keep the US ahead on the innovation curve and on the forefront of this great industry. So the liquefied gas electrolyte has several advantages. Number one, reduced fire risk. So imagine venting or puncturing the cell with a liquefied gas electrolyte in there. That gas is going to quickly evaporate out of that cell very quickly and remove a lot of that fuel from the cell that's otherwise able to burn like a liquid electrolyte would. So that reduces the total heat output upon thermal runaway from your normal lithium-ion cells. And so that minimizes the potential for thermal propagation. We actually heard just a great talk from Honeywell talking about sensing these gases in your battery pack. Well, this would be a significantly easier method to sense the gases upon any venting of any cell within that battery pack. We have the world record temperature range from a minus 60 to plus 60 degrees, by far, bar none. Really good demo actually out in the booth area if you want to go check us out. This is really industry-leading performance, and if you need a low temperature application, we are really the only game in town that can enable those applications. Fantastic material compatibility. We are compatible with all your typical anodes, cathodes, binders, separators. We are taking your conventional jelly rolls from our partners and just adding our electrolyte. No modifications to that jelly roll whatsoever. Increased energy. We are working with partners on the silicon anodes. I actually just got permission about an hour ago to mention our collaboration with Nanograph, so we are working closely with them on some higher energy cells. We're also working with a lot of other groups there to bring us the highest energy materials available to increase the energy of your cells. With these higher energy materials, you increase the tendency for higher thermal runaway reactions and bigger safety issues. Our LiGas electrolyte can minimize those problems. Going to thicker electrodes. We don't have a wettability problem because our electrolytes are very low viscosity and under a little bit of pressure, so they wet these thick electrodes very easily. So enabling higher capacity cells with minimal coating time to lower the cost and improve the energy of your cells. We can also do higher voltage cathodes, maximizing the capacity output from the cathodes we all know and love today. Because of our high conductivity and low viscosity electrolyte, we can also enable fast charge. And we have shown cells charging at 15 minutes or less, no problem, and we are working to improve that further. And last, it's very cost effective. As I mentioned, a lot of these gases are produced on the thousands of metric tons today at a few dollars per kilogram. And using these types of electrolytes, we can minimize the cost of the electrolyte. And we are very gigafactory compatible already as well, with a simple swap out of the electrolyte injection system, which I will show you in a few slides. So the LiGas electrolyte has unique benefits across several industries. Number one is the defense space, which we're working closely on as well. The defense industry is very interested in our technology from a safety point of view, keeping the warfighter safe, as well as enabling these energy storage systems in a variety of temperature environments. Everything from the cold winter nights of Alaska to the hottest summer nights and summer days in Arizona. Industrial. Well, power tools are only power tools at room temperature. If you go down in temperature, they're really just tools. So we solved that issue, putting a nice low temperature battery in these power tools so that utility line workers can repair your power lines in a cold winter storm, keeping you and your family warm in your home at night. Stationary storage. They are really big on cost and safety, two values which we are looking to bring to that industry as well with our LiGas electrolyte. And finally, automotive. We are able to enable the fast charge, the safety, the higher energy, the wide temperature range, and all at a very manageable cost as well. So we are excited to be working with partners today throughout the industry on all these areas, and I want to bring this unique technology to market with you. So today we do have 23 issued patents across the LiGas value chain. Of course, our core competency is on the electrolyte compositions. We have been working to kind of corner off this entire variety of electrolyte compositions that we've been developing with a variety of different gases, which we blend together at Southgate and test. And that brings us to electrolyte manufacturing systems. We built some good intellectual property across blending systems. How do we actually mix these electrolytes and fill it into kegs? We have some good IP around that area as well. But of course, a keg full of really unique electrolytes is no good without an injection system. So we have been designing and building and filing for intellectual property across these electrolyte injection systems. They're actually incredibly simple systems. We do room temperature fills using the inherent pressure differential of our electrolyte to inject into our gases without any mechanical pumps. So there's no worry about salt spray or anything like that when you're injecting your liquid electrolyte. Our gas injection systems are very rapid as well, enabling fast wettability into those cells. So your cell injections would take about an hour today, can be reduced to a few minutes on our systems. And finally, cell mechanical designs. Now, of course, with the moderate pressures that we have inside our cells, we do need unique cell designs. We've modified the venting mechanism on our cylindrical cells to vent at the pressure we need it to vent at, as well as a unique injection port to allow injection of the LiGas electrolyte into the cell and sealing that off very nicely. So we have a lot of intellectual property on these designs as well. So last year I was up on the similar stage at AABC presenting on our Gen 1 LiGas electrolyte chemistry and all the good performance there. So on this plot I'm showing just the cycle life on our Gen 1 chemistry, out to about 1,200 cycles at 100% depth of discharge. Pretty good performance for brand new electrolyte chemistry. I also highlighted our record at low temperature performance. We go all the way down to -60, still cranking at about 40 or 50% discharge capacity out of that. Nobody comes close on this one. We also operate up to 60 degrees Celsius with very good discharge performance as well. Fast charge compatibility is great as well. Over here I'm showing three curves. The red curve is our LiGas electrolyte in an 18650. The yellow curve is showing an identical jelly roll with a conventional liquid electrolyte. We far outperform the fast charge capability. We outperform the liquid electrolyte on this fast charge schedule that we're testing here. We thought that was a really big gap, so we just went online, bought a regular old 18650 Samsung cell and ran that one with the same fast charge protocol, and still outlasting that Samsung cell. We had a good talk earlier from Frederick, thank you, kind of discussing the lithium plating on the graphite under some of these protocols. So we know our LiGas electrolyte has a very highly conductive SCI layer, enabling fast migration of lithium through that SCI, so it prevents a lot of lithium plating under these fast charge protocols. So we've been hard at work on developing new and better chemistries. So today I'm excited to share a little bit of data on our new Gen 3 LiGas chemistry. The Gen 3 LiGas actually features about a 40% reduction in venting pressure, so that lowers the requirements on our mechanical packaging design. It also has about 2 times the electrolyte conductivity than our Gen 1 chemistry. Over here I'm only showing out to 1C, but we actually go out to 2C, 3C all the time, and with very good power discharge performance there. The Gen 1 chemistry showed pretty good cycle life. Our Gen 3 chemistry is only improving upon that. So over here we show Gen 3 chemistry. It's a little past 500 cycles, but projected to be well over 2,000 cycles on these. This is a 2.8 amp hour graphite MZ 18650. And last year I was on this stage, and somebody asked a good question, how is your high temperature stability? Which I replied, we are working on it. And I'm happy to say today that our Gen 3 chemistry is actually performing much better than our Gen 1 chemistry, which showed some fade at 45 degrees Celsius. But our Gen 3 chemistry is showing significantly better stability here. It's pretty early cycling, but we're pretty confident this will be continually cycling over hundreds of cycles with a high confidence level there. I do want to add that our electrolyte is behaving really well at low temperatures, no doubt. If we can enable a high temperature electrolyte that is stable up to 45, 55, 60 degrees Celsius, there is an opportunity there to really minimize or even eliminate your thermal management systems in your battery packs. That can eliminate a lot of cost, weight, and volume. And so that's something to kind of keep your eye on for the future as we continue to develop these really unique electrolyte systems. So it's great that we have this really unique electrolyte system, but what else can we really do with it that only we can do? So today we are actually looking towards the LNMO cathode to use that as a next generation electrolyte system to help grow the electric vehicle market. For those of you that don't know, the LNMO cathode is a high voltage spinel, has no cobalt and a very low nickel content in there, which means it's a very low cost, about the same cost, dollars per kilowatt hour, as LFP, but has the watt hours per kilogram of NMC materials. So it's the best of both worlds. It's the perfect opportunity to be introduced into the electric vehicle market, and I'm sure every automotive OEM would be really interested in this material. It also has improved safety due to that stable crystal structure. It kind of locks in those oxygen atoms in there, so during your thermal runaway events, less oxygen is released, preventing the peak temperatures that we're all used to seeing and very scared of. It's a high voltage cell, so you require less cells in series to match your battery pack and module system voltages. And finally, it's a spinel crystal structure, which means it's a three-dimensional structure, lithium come in from any direction, which allows for very high power and excellent low temperature capability. But the problem with this cathode all along has been the high voltage stability of electrolytes. Because it's operating at such a high voltage, these electrolytes tend to break down, and you get very little cycle life out of very little performance. So we believe our LiGas chemistry is actually an enabler for this high voltage cathode. And so we actually have won an award from RBE to explore this cathode specifically, and we are working with project partners to that end. And so today we're working with partners to enable their LNMO materials. So over here we're showing a select of 5 group of suppliers that manufacture LNMO cathode materials today. So obviously we're screening them, seeing how the life performance is with our materials. There's some good ones, there's some bad ones. You figure that out, because it's still a new material and people are still trying to figure out how to manufacture this. So we are down selecting which vendors actually show the best performance right off the bat. And we're also doing some high power testing. So over here, as advertised, the LNMO is a spinel structure. It should show very good power. And here we're showing up to the 5C symmetric charge and discharge rate, really good capacity retention. This is an excellent material to enable fast charge needs in the automotive industry today. Now, of course, these are all coin cells. A lot of people always say, well, you got to show a full cell data. You got to go to 18650 form factor. And well, that's what we're actually working on. So today I'm happy to share with you just some preliminary data we have on these graphite LNMO full cells in an 18650 form factor. So the 2 red curves are showing these graphite LNMO cells. The solid curve with our LiGas electrolyte, the dashed curve with your conventional liquid-based electrolyte. At room temperature, they're showing pretty similar voltages, nominal voltage right around 4.6 volts or so, and both very tracing right on top of each other about. When you start to drop the temperature down to minus 20 degrees Celsius, you see the liquid voltage curve just drop right out. That electrolyte is just essentially freezing, or salt is precipitating, who knows what's happening in there. But it's not performing very well. As we all know, the liquid electrolytes just don't do well at low temperature. The LiGas electrolyte shows like very little, if any, degradation whatsoever. Really getting essentially all of your energy out of that cell still. Now, one thing we like to do at South8 is really show off our low temperature capability. So here we're showing down to -40 and -60 degrees Celsius. It's kind of ridiculous that we're still getting such high voltages and capacity retention at -60. Nobody really needs that for automotive purposes. Maybe if Elon Musk decides to shoot another Tesla to Mars or something, maybe he might want that. But at -40 degrees Celsius, which is where a lot of the automotive industry would be like the very minimum at the temperature range, we're still showing close to 90% of your energy retention. That's really, really impressive. It's essentially going to be working in any temperature you give it. So that's really a unique benefit of our chemistry here. Now, of course, we all know the challenge with LNMO is the cycle life, and that's one thing we're looking very closely at. So over here we show your cycle life with these LNMO cells. The purple curve showing your conventional liquid electrolyte crashing out relatively quickly over the first dozens of cycles. The blue curve is our Gen 1 liquefied gas electrolyte. A little bit better. It's still not to where it needs to be. Our Gen 3 electrolyte, which I just introduced you all, is actually performing considerably better. And we kind of understand where a little the hiccups are on that one. So we're rapidly evolving this electrolyte chemistry to actually perform significantly better cycle life on these full cells. So I'm very excited to kind of next year be discussing what we have done since then. We'll continue to improve that cycle life at room temperature, but also at high temperatures. Evaluate that manganese dissolution, which we all know is an issue with these cells and chemistries. We want to improve that cell design to optimize for cell capacity, and probably partner with silicon anode manufacturers to further improve the cell energy and fast charge capabilities. Imagine a pairing of the silicon anode and an LNMO cathode. You would have the ultimate fast charge capability among all their cell chemistries. So that's something we're really looking forward to bringing to you. So a few years ago, we introduced our prototype cells to select partners and started sampling those out. Big clunky looking header on that thing. We were purchasing a lot of off-the-shelf components. You have this burst disc over there, this little hermetically sealed feed-through pin, a little check valve for electrolyte injection. All these off-the-shelf components required us to make its custom header, which is really big and clunky. We've since engineered a really nice pre-A cell, which we're calling it, with a really slim header, laser welded on there with a really unique injection port and the vent on there, so it's a little smaller form factor. And we continue to reduce that form factor in these new A cells that we'll be releasing next year in 2024. True to form factor 18650s and 2170s that we're excited to be releasing next year. But this year we are, actually today we're putting out about 20 cells per day on the pilot line, and we'll be ramping that up to about 100 cells per day later next year. And we're pushing out 18650s and 2170s to all of our good partners out there in the industry. So we're really excited to announce this week the release of our Arctic cell, our really robust 18650 cell that we've released to the world to meet the most aggressive of your temperature challenges at these low temperatures. And I did promise all of you a video at this end of this talk, and so happy to share with you the South8 LiGas Flashlight Challenge. So over here we have a South8 Arctic 18650 cell, fully charged to 4.2 volts, which we are going to insert into this flashlight over here. Going to flash a brand in there to advertise the flashlight company. And then we have a off-the-shelf Samsung 18650, which is also fully charged to your 4.2 volts. Also going an identical flashlight, and both put into this bucket of dry ice. And we're going to go ahead and dump some dry ice right on top there, keep it nice and cold. And you'll see in a few minutes that temperature dropping to -70 degrees, -80 degrees, and that liquid electrolyte just begins to fill right there. So you see that flashlight turn off after about 7 minutes. That stuff just freezes up, doesn't really give you any performance. The LiGas electrolyte continues throughout the day, overnight, into the next morning, and finally, about 18 hours later, that flashlight finally dies out. Really an amazing technology for anyone that needs that ultra-low over temperature range. But you know, it's so much more than a low temperature electrolyte and technology. I think I shared that with you all today. So I hope you can all really appreciate that we're bringing real innovation to this industry today, but with a really secure supply chain that's right here in the US today and really can keep us at the forefront of this unique technology. A quick thanks to our investors and supporters out there, and additional names to be added to this list once we can publicly announce them. And finally, I thank you to all of you. Thank you so much for your time.